Hey everyone, today we're going to look at a few problems from problem set 17 in the 7th grade Engage New York Module 1 workbook. It says, question 1 says, Giovanni went to Los Angeles, California for the summer to visit his cousins. He used a map of bus routes to get from the airport to his cousin's house. The distance from the airport to his cousin's house is 56 kilometers, and on his map, the distance is 4 centimeters. So what is the scale factor? So we're scaling these bus routes down from 56 kilometers to 4 centimeters. That's going to be a super small scale factor to go from something so big to something so small. So I already know my scale factor is going to be way smaller than 1. Let's figure it out. So question 1. The original distance was 56 kilometers, and the new distance is 4 centimeters, and my scale factor, which I'll abbreviate as SF, will be the new divided by the original. But the thing is, we can't just do 4 divided by 56 because they're in different units. I have kilometers here and centimeters here, so we need to put them both in the same units before we can do that. I think it's probably easier to put kilometers, convert kilometers into centimeters than the other way around, just because that way we're still working with whole numbers rather than some crazy small decimal. So I'm going to convert 56 kilometers to meters because I know kilo means 1,000. So this is 56,000 meters. And then I know that there's 100 centimeters in every meter, so this is equal to, let's see here, I'm going to add 2 more zeros to this, so 5,600,000 centimeters. So now I can do my scale or new measurement divided by that original measurement and get this super tiny scale factor. So the scale factor is going to equal 4 divided by 5,600,000, and I'll just divide the top and the bottom of this fraction by 2, and so that gets me 2 over 56 divided by 2 is 28, so 2,800,000. And I see that 2 can go into the top and bottom again, so I'll divide the top by 2 and I get 1. And I divide the bottom by 2 and I get 1,400,000. So there's my scale factor right there. Super small, 1,400,000th. Okay, let's move on. Number 2. Number 2 says, Nicole is running for school president. Her best friend designed her campaign poster, which measured 3 feet by 2 feet. So that's a rectangle. One side's 3 feet, one side's 2 feet. Nicole liked her poster so much, she reproduced the artwork on rectangular buttons that measured 2 inches by 1 1/3 inches. So 3 feet is longer than 2 feet, and 2 inches is longer than 1 1/3 inches. So I know that these two measurements correspond to each other, and these two measurements correspond to each other. And so I'm going to find the scale factor. But honestly, I don't even need all these measurements. If I'm going to find a scale factor and I know that it's a scale drawing, they're telling me that, then I can just use the easier of the two pairs of numbers. I'm going to use this 3 and this 2. So once again, we have a unit issue though. They gave us feet for the original and inches for the reproduction. So question 2. The original had a side length of 3 feet and a new side length of 2 inches. And so I want to find my scale factor, which will be the new divided by the original. And so I got to do the same thing as I did before. I got to convert this feet to inches. I think it's usually easier to convert the bigger unit down to the smaller unit. That's just a preference of mine. So 3 feet times 12, oops, I was gonna write that backwards, inches per foot equals, well, 3 times 12 is 36. So that's 36 inches. And so if I want to do the new divided by the original, I'm going to do 2. So this is for the scale factor now. Divided by 36, which is 2/36, and I can reduce that down to 1/18. So my scale factor in this case is 1/18, which makes sense. That's a very small scale factor, and we're scaling something down from 3 feet long to 2 feet long. All right. Let's move on to number 3. Number 3 says, find the scale factor using the given scale drawings and the measurements below. Oh, okay, so we're doing this one with the batteries. We got the actual or original, as I say often in class, is 3 centimeters, and the scale drawing is 5 centimeters. I'm just gonna do this one right in the book. The scale factor is scale divided by actual, or new divided by original, like I say a lot. These mean the same thing. So I'll do scale divided by actual, which in this case is 5 divided by 3. That's just 5/3. You don't need to put that into a calculator and figure out that it's 1.6 repeating or whatever. Just leave it as 5/3. There's your scale factor. Okay, moving on to number 4. It says find the scale factor using, okay, same thing, right? This time the scale drawing is smaller than the original or actual drawing, so we should have a scale factor that is smaller than 1, where last time we had a scale factor that was bigger than 1. So I'm just going to do scale factor equals, this time I'm going to write it as new divided by original. This means the same thing as scale divided by actual, just different words. So scale factor will equal 6 divided by 24. And I see that I could divide the top and the bottom of this fraction by 3, and that would give me 2/8. But I see that 2/8 is also equal to 1/4. So you would say that this ball is 1/4 the size of this one, or scaled to 1/4 its size. All right, let's move on to the next page. So I'm going to leave the drawings in question 5 up to you. I will look at question 6 real quick though. It says, Hayden likes building radio-controlled sailboats with her father. One of the sails, shaped like a right triangle, so that's a triangle with a 90-degree angle, should look like that, has side lengths measuring 6, 8, and 10 inches. Okay, I know that that works because 6 squared is 36, 8 squared is 64, and when you add those up, you get 10 squared, which is 100. And I know that when in right triangles, the square of one side plus the square of the other side should equal, oops, not plus, should equal the square of the longest side. So I'm thinking of this A, 6 is A, 8 is B, and 10 is C. So I did a quick check just to make sure that worked. You didn't have to do that. That was extra. That's called the Pythagorean. I hear people say it different ways. Theorem. Maybe an extra credit question on a quiz. So, to log her activity, Hayden creates and collects drawings of all the boats she and her father built together. Using the scale factor of 1/4, create a scale drawing of the sail. Okay, so I just need to scale 6, 8, and 10 down to 1/4 of their size, each one. Okay, so let's make a little table. We have our original measurements and our new measurements. and it said that there were side lengths of 6, 8, and 10. And we're going to multiply each one of these by our scale factor. So we're going to do times 1/4, times 1/4, times 1/4. And so this is 6/4, this is 8/4, and this is 10/4. That's kind of hard to do on a ruler though, so maybe we could put these into mixed numbers just so it's easier to see. So this would be 1 and 2/4 left over, which is a half. So that's 1 1/2. 8 divided by 4, that's just 2, so that's easy. I'm going to put inches next to each one of these to remind us that it's inches. And then 10/4. So 4 goes into 10 2 times. There'd be 2/4 left over, which is equal to a half. So 2.5 inches. And so to finish this problem, you would just draw a right triangle that has a base of 1.5 inches. Oops, I almost used the centimeter side. Remember, the inches side is the side with the bigger spaces between the numbers. So let's see here. 1.5, about like that. 2 inches for the height. So I'll line my 0 line up right with the line that I just made. I'll try to make a 90-degree angle. Probably won't be perfect, but 2 inches. And then because I trust the Pythagorean theorem, I know that this, from this point to this point, should be 2.5. And it is. So there's my 1/4 scale drawing of her sail. Okay, there's problem set 17.